Hello everybody, welcome all to this special session on how to use Ftool software. In our DME course of module 2, we have one numerical in the practical part, or rather we have two or three numericals in the practical part that requires us to use the Ftool software. So let us see how to use this software, and how to solve this numerical. First, we have to download this software from the link given in your practical part. So here I have this software that I have downloaded. Now what I'll do is I'll open it. So as soon as I open it, you'll notice that the software opens out. Now let us see some of the important tools of this software. So this is a tool software. Here you can see the data related to the material properties. From here you can input the section properties. From here you can select the various types of supports. Then from here you can put the various types of forces like point loads, that is nodal forces, then the moments, then uniformly distributed loads, linear loads. Then you can, with these options, you can make the shear force diagram and the bending moment diagram. So this is the numerical that we have to solve. This is similar to the one that you have in your practical part. I have made some changes in the values. So here we have been given the numerical, that is use Ftool software for this numerical. Consider the following specifications for a concrete beam. So we have a concrete beam of material, isotropic material. Then the beam length is 12 meter. It is simply supported at 0 meter and 10 meter. Then we have a roller support at 0 meter and hitch support at 10 meter. Cross-section dimensions are given for the beam as 350 mm by 250 mm. This is the value of modulus of elasticity. There is a point load of 80 kilonewton, acting at x is equal to 12 meter, and there is a distributed load of 20 kilonewton, acting from x is equal to 0 to x is equal to 10 meter. So now let us see what we have to do. We have to first make this beam with the various supports and the various loads. So we have to take the screenshot of the beam with the various supports and the loads as per the given specifications. Then we have to find out the values of vertical reactions at the two supports. And we have to show them and get their values. We have to take their screenshot also. So let us see, we can divide this beam into two parts. The length of the beam is 12 meter. We can divide it into two parts. First part is, let us say, from 0 to 10 meters, and the further part is, let us say, from 10 to 12 meter. So let us start using this Ftool software. So initially I'll use this keyboard mode. I'll use the software with the keyboard mode. So I'll press on this keyboard. Now I'll select, so I'll just press on this keyboard mode and I'll select this insert mode. First I'll insert the nodes, 3 nodes corresponding to two parts of a beam. First from 0 to 10 meter, then from 10 to 12 meter. So let us select this node. So this node will start at 0 meters, let us say. And let us say the height is about 4 meter, or let us say about 5 meter. So that is the first node starting. The beam will start from 0. Then the second node is, let us say, at 10. So I'll put 10 over here. This y coordinate will remain as it is. Yeah, so here you can see this first node. Now I'll press. So what I've got is uh, I'll now press OK over here. So I've got this second node also. Yeah, now to get this third node, I'll put 12 over here. So I'll be getting the total beam length of 12 meter. So here you can see this third node. Okay, now I'll close this window. Okay, yeah. Now I can stop this keyboard mode. What I'll do now is I'll draw the member. Yeah, corresponding to these three nodes. This is 0 to 10 and then 10 to 12. Yeah, so I'll just draw this insert. Now I can use the mouse. Insert. Uh, yeah, so let me just do it properly. I hope this has been closed. Sorry. I'll just undo this. I'll just pick up this member and I'll draw this from, this is the first point and then the second point. Yeah, and then again from here to here. Yeah, to I can now insert the dimensions. So here this is the dimensions line. Yes, so here you can see now. I'll just click on this. I'll go up to this for second node. Yeah, I'll be able to get the dimensions of this one. So this is 10 meter. Yeah, then again click on this second node, click on the third node, then I'll be able to get the dimensions of this part. So you can get the total length also. Yeah, like I can start from here. Yeah, and then end it over here. So I can get the total dimensions also. Yeah, that is how we have to do. So we have made this beam of 12 meter. Now what we'll do, we'll insert the supports. Yeah, so here this is the supports button. Yeah, so here we will require the, let me select this, we'll require the support over here. So I'll just select this node number 1. So here these are the various supports. At this point, at the first node, let us say this one, we require this roller support at 0 meter. Yeah, at 0 meter we require the roller support. So at this node we require the roller support. So here you can see these are the options for the support. Yeah, here X displacement, that means the roller is allowed to move in X direction. The roller support is allowed to move in X direction. It is not allowed to move in Y direction, so it is fixed. It is allowed to rotate above the axis, so this is kept free. Yeah, so now what I'll do, I've already selected this first node. Now what I'll do, I'll click on this, apply support conditions to this selected node. So as soon as I apply this, you can see the roller support has come up over here. Yeah, now we require the hinge support over here, let us say at second node. Yeah, so now what I'll do, I'll take this button, select option, and I'll select this support. Yeah, now this is a hinge support. For the hinge support, as we know, the X displacement is not allowed, so it is fixed. Y displacement is not allowed, it is fixed, but the rotation is allowed, so it is free. Yeah, so what I'll do now is apply the support conditions to the selected node. I have already selected this node, so you can see this second support, that is the hinge support, has come up. Yeah. Now the next thing that I have to do is we have to insert the point load. Let's see this numerical. Yeah, so simply supported beam supported, sorry, this is the numerical that we are talking about. So we have this beam of 12 meter simply supported at 0 and 10 meter. Yeah, then we have roller support at 0 meter and 10 meter. Yeah, then I'll just close this one which is not required. So the 0 meter and simply supported at 0 meter and 10 meter, we have taken this. Yeah, roller support at 0 meter and hitch support at 10 meter. Then we require point load at 12 meter. Yeah, so let us insert first the point load now. So I'll go to this software. So here this is the option for nodal force, that is the point load. I'll click on this. Now here you can see this nodal loading. There is none option. So what I'll do is click on this create new nodal force. Yeah, so create a new nodal force. Let us say this is point load. Let me click on this done button. Yeah, now it will ask you to put the values of horizontal and vertical forces. Here we do not have any vertical forces. We have only the horizontal force of 80 kilonewton at x is equal to 12 meter. Yeah, so what I'll do is I'll put this value of 80 kilonewton over here. Since it is downward force, so it will be minus 80 force. Yeah, it will be required on this node. Yeah, I have selected this option, arrow option, and I've selected this node. This is where it is required. So what I'll do, I'll click on this apply nodal forces to selected node. Yeah, so this force has come up. Yeah, now we require uniformly distributed load between these two supports. So what we'll do now, we'll go to this uniformly distributed load. Yeah, again the same thing. Yeah, now we will create a new uniform load. Yeah, create a new uniform load. Let us call it as uniform distributed load UDL. Yeah, let us click on done. Yeah, let us click on this local. That means it has to be located between two certain points. We have a vertical load that is minus 10, minus because it is acting in a downward direction. We have been given, sorry, minus distributed load of 20 kilonewton from x is equal to 0 to x is equal to 10. So this should be minus 20. Yeah, it has to be located between the two points. Yeah, so these are the 2 points between which it has to be located. So I'll select these. Yeah, and then I'll click on this apply uniform distributed load to this selected member. So you can see this load has come up now. Yeah, so this is a complete diagram that we'll be requiring for this first part of the question. Yeah, so you can take the screenshot of this. Yeah, so you can just go to this options. Yeah, like here also you can see this option, that is copy the screen to clipboard. So you can click on it and just paste it to the answer sheet, or you can take the complete screenshot. Yeah, then you can go to this display option. Then here you can see this option of reaction values. When you click on this, yeah, when you click on this, uh, the reaction values will be displayed. I think first I'll have to put the data, then this reaction values will be displayed. Yeah, so this is the beam diagram. To make the shear force diagram, the bending moment diagram, and to get these various reaction forces, we'll put the material data and the cross section data. Yeah, let us put first the material data. So let us click on it. So yeah, the material parameters will come up. Yeah, here you can select on create new material parameters. Yeah, so you can give any name. Yeah, so the material types here, this is a concrete material, so let us say it is a concrete isotropic material. Isotropic means it has a similar properties throughout the section. Let us click on done. Click on this apply to all, that means it will be applied to all the members. Yeah, let me put these values of E. The values of E have been given to you as, yeah, 220000 MPa. So let us put these values 220000 MPa. So let us put this value 220000 MPa. Apply it to all. Yeah. Now let us go to the section properties. These are the section properties. Again, so here you can see the section properties. So let us click on new section properties. Yeah, let us assume that we have been given that this is a rectangle. So let us say this is a rectangle. Yeah, so this is a rectangle. Click on rectangle and then click on this done. Yeah, let us consider these D and B properties, depth and width. So these are the values that have been given to you. Yeah, 350 and 250 mm. So let us put these values 350 and 250 mm. So yeah, this is, let us say 350, yeah, and 250. Yeah, let us click on this apply current section to all the members. So all the members will have similar section. Yeah, so that is how. Now I suppose you will be able to see these reaction values. Yeah, so you'll be able to see the reaction values as well. They're not visible. I'm not sure why. Maybe. Okay, that is how you'll be able to get the reaction values also. So this was the first part of the question. Yeah, that is, show the screenshot of the beam with the various supports and the loads and give the values of vertical reactions at the two supports. Yeah, so these reactions should get displayed as such over here, but it looks like they are not visible due to some. Okay, then in the next part, what you have to do, let us open our original assignment. Yeah, so in the next part, what you have to do is, so this is the first part, first question. In the second question, you have been asked to make a shear force diagram, take its screenshot, and give the values of shear forces at the two supports. Yeah, so what we can do over here, you can see the shear force. I'll click on this. As soon as I click on this, I'm asked to save this file first. Yeah, so what I'll do, I'll save this file. Yeah, so I'll name this as, let us say, trial 8. I'll save this, and here you can see the shear force diagram. Yeah, if you want, you can remove these dimension lines. yeah, to make this visible clearly. So here this is a shear force diagram, and you have been asked to get the values of shear force diagram at the two supports. So this is the value 84 kilonewton at one support, and this is the value 96 kilonewton at the other support. It is getting converted from negative to positive value. Yeah, then you can click on this to copy the screen to clipboard so you can get the screenshot. Yeah, then what you have to do, you have to go to the next question, get the make the bending moment diagram and give the values of maximum bending moment and the minimum bending moment, positive and negative values. Yeah, so yeah, what we can do now is, sorry, let us open this software once again. Now you can click on this bending moment diagram. Yeah, so when you click on this bending moment diagram, you get this bending moment. This is the 176 is the maximum negative value, and 160 is the maximum positive value. Yeah, so you get both these values. Yeah, so you can give the values of maximum bending moment and the minimum bending moment. You can find out its location, their location also. Yeah, so their locations are also can be found out by considering this x coordinate and y coordinate. This x coordinate will give you the location along the beam. So here it's 4.21 meter. Yeah, so this x value, yeah, this will give you the location. Then similarly, give the value of minimum bending moment and its location. Give the point or location from the left where the bending moment is converted from positive to negative or from negative to positive. Yeah, so here it is getting converted from negative to positive. Yeah, yeah, so you can find out its location. So that is how we have to solve this numerical. I hope everybody has found this quite useful. If you still have any doubts, you can always contact me. So thank you very much for joining me.